Assalamualaikum, welcome to our video. Today we would like to share with you guys our solution for question 4. And without further ado, we will continue with the solution for the question given. And so, the first step we take is to form the system of linear equation. From the question above, we can get 5 linear equation, and from the 5 linear equation we can form a system of linear equation. The first linear equation we get is x1 plus x2 equal to 20. The next one is x2 plus x3 minus x4 minus x5 equals to negative 10. The third equation is x3 plus x6 equals to 30. The fourth one is x1 plus x4 minus x7 equals to 0. And the last one is x5 plus x6 equals to 35. From these 5 linear equations, we can get a system of linear equation. For step 2, we need to solve the system. And our group has decided to use the Gaussian elimination method. And the first step for this method is we need to create or form an augmented matrix from the system given. From the augmented matrix that we get, we need to transform it into row echelon form. From the augmented matrix, we can see that the first non-zero entry is 1. So this is the leading one for the first row. And then the next step, we need to make sure that everything below the leading one is 0. And from this matrix, we can see that there are number 1 at row 4. So we need to do elementary row operation into the matrix to make it into 0. And so the formula is negative row 1 plus row 4 placed into row 4. And from that operation, we get this matrix. Now we proceed to second row. We will repeat the process that we have done in step 2 for the second row. The first non-zero entry in the second row is 1, and this is the leading one for this row. And then we need to zero out everything under the leading one. To do this, we need to use the elementary row operation. To zero out the negative one under the leading one, we need to add R2 with R4 and place it into R4. Next, we will proceed to row 3. We will repeat all the process we have done before for row 3. The first step, the first non-zero entry for row 3 is 1, and this will be the leading one for the third row. Next, we need to zero out everything under the leading one. We will add negative R3 with R4 and place it into R4 to zero out everything under the leading one. Next, we will proceed with row 4. For row 4, the first non-zero entry is negative 1. So, we need to change it into positive 1. To do so, we use elementary row operation.
Assalamualaikum, my name is Firdaus and I will continue to solve this problem. To solve the problem, we're gonna use elementary row operation. That is, the formula is negative R4 over 1 change in R4. After we get the linear one, we need to change all the values to 0 under the linear one. To do so, we can use elementary row operation. The formula is negative R4 plus R5 change in R5. Next, we're gonna proceed with row 5. Row 5 is the last row in the matrix. So we can solve this problem using elementary row operation, that is negative R5 over 1 change in R5. Because they don't have any number under row 5, we don't need to cross any numbers. Finally, we get the row echelon matrix. Next step, we will turn the matrix into linear system equation. As you can see, in x4 and x6, there is no linear one. Hence, it is free variable. We can present it with parameter that is for x4 is t and x6 is f. Next, we can solve the system using substitution method. After that, we get the answer for our equation. That is x1 equal to 25 minus x4, x2 equal to x4 minus 5, x3 equal to 30 minus x6, x5 equal to 35 minus x6, x7 equal to 25, and x4 and x6 is a free variable.
Beside Gaussian elimination method, we can also use Gauss-Jordan elimination method. For that method, we only need to zero out everything under and above the leading one, and we will get the same answer as given. And that's the end for our question. Before we end our video, I would like to thank you, Dr. Shamsatun, for giving us the opportunity to do a video for our assignment and for help us completing our assignment. So thank you for watching. Assalamualaikum.